is pre-algebra lesson 5-2, fractions and decimals. A terminating decimal is a decimal that ends and has no repeating digits. If something terminates, it ends. For example, if someone was to terminate my employment, that means they fired me. I would be sad because I would be without a job because it ended. A repeating decimal is a decimal in which the same blocks of digits repeat without end. Normally, a repeating decimal, the blocks of digits that are repeating are shown with the repeating block. For example, you might see 1.3 repeating. That means only the 3 is repeating. But I could have something like 2.0734, where all the 0734 has a bar over it, meaning that the 0734 repeats. So it's 2.0734, 0734, 0734. So whatever has the line above the top of it, those are the digits that repeat in that particular order. Now it's helpful to be able to convert between decimal numbers and numbers written as fractions, because you'll find sometimes it's more helpful to deal with the decimal, and sometimes it's more helpful to work with the fraction. So we're going to learn how to convert both of them today. To convert a fraction to a decimal, divide the numerator by the denominator. In other words, divide the top number by the bottom number into top number. Place a bar over any group of digits that repeat, if it's necessary. Sometimes they don't repeat. So we're going to convert each one of these fractions to a decimal, and we're going to state whether or not each decimal is terminating and repeating. And of course, if it repeats, we'll state the block of digits that repeat. Okay, so let's take a look at this. 5/6. If we're going to change this to a decimal, that means we're going to take the denominator, the 6, and divide it into the numerator, the 5. I'm going to add a decimal point and several zeros because I'm not sure how many I need. 6 does not divide into 5, so I'll put a 0 up there. 6 will go into 50. Let's see, 6 times 7 is 42. 6 times 8 is 48. So I'm thinking 8 times here. 6 times 8 is 48. 50 minus 48 is 2. Bring down my 0. 6 goes into 20 3 times. That's 18. 6 goes into 20 3 times. Aha, I see a pattern here. I do believe this 3 is repeating. Just the 3, not the 8. So my answer to this would be 0.83 with a bar over the 3. This is a repeating decimal, and the digits that repeat, okay, if the decimal repeats, take the digits that repeat, the repeating digit is just the 3. Okay? So we have changed 5/6 into a decimal, 0.83 repeating, which means only the 3 repeats. Let's look at 7/11. Same thing. We're going to take the bottom number and divide it into the top number. And I'm going to put a 7 here, a decimal point, and a whole bunch of zeros. Bring that decimal straight up. 11 doesn't go into 7. 11 will go into 70 6 times. 6 times 11 is 66. 70 minus 66 is 4. Bring down my 0. 11 goes into 40 3 times. 3 times 11 is 33. 40 minus 33 is 70, or 7, and bring down the 0. 11 goes into 70 6 times. I'm seeing a pattern here. 6 times 11 is 66. I'm going to have a 4 here. Notice what's repeating is both the 6 and the 3. So this answer would be 0.63. Both the 6 and the 3 repeat. It's a repeating digit. It's a repeating decimal, excuse me. Let's see if we can spell repeating right. R-E-P-E-A-T. If the repeating decimal, the digits that repeat are the 6 and the 3. So changing a fraction into a decimal. And it doesn't even matter if it's a mixed number. Sometimes you'll get a mixed number. If you get a mixed number, just put that mixed number as a whole number in front of your decimal. Because if this would have been 2 7/11, it would be 2.63 repeating. That's all you have to remember is if you get a fraction in front, you can either change that fraction to an improper fraction and then divide, or divide like normal and then add that whole number in front of it. Sometimes it's better to use the fractional part because you forget the whole number part. To convert a decimal to a fraction actually is a little bit easier, unless it's a repeating decimal. You find the place value of the last digit, write the number over that place value, and then reduce the fraction if necessary. For example, 0.56. The 6 happens to be in the hundredths place. Okay, this is in the hundredths. So this becomes 56 hundredths. Okay, 56 over 100. And I know 56 over 100 reduces. I know at least by 2, but remember we learned those divisibility rules back in chapter 4 so that we can reduce fractions much easier. I happen to know that 100 is divisible by 4 and 56 is also divisible by 4. So if I divide by 4, 100 divided by 4 is 25. And 56 divided by 4 is 16, I do believe. And let's take this out. 56 divided by 4, 4 is another 1 time. Not 14, not 16. My brain is not functioning properly. Always good to check. 14/25. So there we have that fraction as a nice reduced fraction. As a fraction versus a decimal. 1.72 is 1 and 72 hundredths, or 172 over 100. Okay, so we now know it's going to be a mixed number. Okay? It's 1 and 72 100ths. And I can reduce the 72 over 100. Okay? Again, 100 is divisible by 4. 72 is also divisible by 4. So 100 divisible by 4 is 25. 72 goes 4 goes into 72. 4 goes into 18 times. So it's 1 and 18/25. Okay, no way do I want you to use calculators because calculators can do this for you. And I want you to learn how to do this all by yourself because you're not going to be able to use the calculator on the final exam. 0.65. Again, the 5 is in the hundredths position. So this would be 65 over 100. Hey, it ends in a 5 or a 0, so I know it's divisible by 5. 65 divided by 5 is 13, and 100 divided by 5 is 20. So this becomes 13/20. 2.32, or 2 and 32 100ths. Seem to like the hundredths, don't they? So 2 and 32 over 100. I know that both 32 and 100 are divisible by 4. So this would be 2, 4 goes into 32 8 times, 4 goes into 125 times, 2 and 8/25. So converting decimals to fractions, converting fractions to decimals. Now, when comparing and ordering a list of numbers that contain both fractions and decimals, you have to determine whether you think it would be better to write it all as fractions or all as decimals. It all depends upon which one you think will be easier, finding a common denominator or not. Me personally, unless they look really hard, I try to put them all into decimals because that seems to be easier than finding a common denominator. So if I have 0.2, 4/5, 7/10, and 0.5, I'm going to change all of these to decimals. 0.2 already is a decimal. 4/5, okay, 4/5, I know what that is as a decimal, but you may not. 5 dividing into 4. Okay, 5 does not go into 4, but it goes into 48 times, so that's 0.8. 7/10, hopefully you know that, that's 0.7. Okay, 7/10, 0.7, first decimal place. So if we were to order these from smallest to largest, this is my smallest number right here. My second smallest number is right here. My third smallest number is here, and my fourth smallest number is here. And I write the numbers like that so that when I go back, I can rewrite them in their proper original form. Because if you order something, you have to put it back in its original form. So from smallest to largest goes 0.2 is first, then goes 0.5. Then we have 7/10, and last but not least, we have 4/5. And that's ordering the numbers from smallest to largest. Now, writing a repeating decimal as a fraction. Now, this is a fairly difficult concept. However, if you follow the steps, and you can walk through the steps, it's not as bad as you think it is. And we're going to write 0.18 repeating as a fraction. To do this, there's a process. There's just a step-by-step process you need to do every single time. Okay, the first thing you do is you let a variable be equal to your decimal. And it has to start with the repeating part. In this particular problem, both the 1 and the 8 repeat, so I can let n equal 0.18 repeating. If there was a digit in front of the 1 that did not repeat, I would have to do something different, so we'll go through a problem that looks like that a little bit later. Now, because 2 digits repeat, I need to multiply both sides of my equation by 100, because 1 followed by 2 zeros is 100. If I wanted to get rid of those 2 digits that repeat, I would have to multiply by 100. If 1 digit repeated, I'd multiply by 10. If 3 digits repeated, I'd multiply by 1,000. Since 2 digits repeat, I multiply by 10 to the second. If 5 digits repeated, I multiply by 10 to the 5th power, which happens to be 100,000. It's just the way it works. So, since 2 digits repeat, I'm going to multiply both sides of my equation by 100. So I would have 100n equals 18.18. Because if I take 0.18 repeating, remember 0.18 repeating is 0.18181818 forever. If I multiply by 100, I'm moving the decimal point 2 places to the right. So I'm going to have 18.18 repeating. So that's what I have here. I multiply both sides by 100, and I get 100n equals 18.18. Now that you have this, you have 2 equations. I'm just going to basically subtract the second equation from the first equation. Okay? Or basically what you have is you have this. N equals 0.18 repeating. That equals 100n, okay, plus whatever. So I'm just going to subtract the smaller one from the bigger one, because it's a whole lot easier to subtract the smaller one from the bigger one. So I'm going to subtract n and subtract 0.18 repeating. So basically I took this equation right here and I subtracted it from the 100n equals 18.18. So 100n minus n is 99n, because 100 minus 1 is 99. 18.18 repeating minus 0.18 repeating means the repeating part goes away, which is good because that's what I needed to happen. So I now have 99n equals 18. So now that I know that 99n equals 18, I just need to solve for n, so divide by 99. And of course, we need to reduce the fraction if possible, and in this particular case, I happen to know that both 18 and 99 are divisible by 9. So if I take it and divide it by 9, 18 divided by 9 is 2, 99 divided by 9 is 11. So 2 11ths is 0.18 repeating. The more you do these, the better you get at them. And let's take a look at a couple of them, since this will help us immensely. We're going to write each as a fraction in its simplest form. So I have 7/10 repeating, or 0.7 repeating. So my first step, there is no digit in front of the repeating digit, that's after the decimal point. So I know that n can equal 0.7 repeating. In order to get rid of that decimal point or move it, I need to multiply it by 10, because there's only 1 digit repeating. 1 digit repeating, multiply by 10. 2 digits repeating, multiply by 10 to the second power. 3 digits repeating, multiply by 10 to the third power, etc. So now I know I'm going to multiply both sides by 10, so 10 n equals, remember 0.7777, if I multiply by 10, I get 7.7 repeating. So I will take my smaller equation and subtract it from my larger equation, so I'll subtract n and subtract 0.7 repeating, and you'll get 9n equals 7. Divide by 9, divide by 9, n equals 7/9. And at this point in time, somebody always asks me, do all repeating digits always end with a 9? Do they always have a 9 as a denominator? No. Don't get stuck into thinking that everything's going to end at 9 or 99. It's not. Okay, let's just have a neat coincidence. Number 2, we have 0.213 repeating. Now we have 3 digits that repeat. So n is going to equal 0.213 repeating. So now I need to multiply by 1,000, or 10 to the third power. So 1,000n equals 213.213 repeating. So now I'm going to subtract the smaller one from the larger one. So I'm going to subtract n and subtract 0.213. Remember, everything you do to get rid of that repeating decimal. 1,000n minus n is 999n. 213.213 minus 0.213 is 213. Divide by 999. n equals, let's see here. I know it's divisible by at least 3 because 9 plus 9 plus 9 is 27, which is divisible by 3. 3 plus 2 is 5 plus 1 is 6, which is divisible by 3. So if I divide this by 3, I get 71 over 333. And that is as low as this fraction will go. So we get 71 333rds. Notice it doesn't end in a 9. All right, let's take a look at number 3. And I'm going to move number 3 down a little bit because I need a little bit more space. Okay, it's 0.213 repeating, but the only thing repeating is the 1, 3. 0.213 repeating. The difference between number 2 and number 3, if you look at it, number 3, or number 2, the 2, the 1, and the 3 are repeating, and in number 3, only the 1 and the 3 are repeating. So the first thing I do is I need to get it so only the repeating digit is after the decimal point. So instead of saying n equals 0.213, I'm actually going to make sure that this gets moved, so I can multiply by 10 right off the bat. So this is going to be 10n equals 2.13. The only digits after the decimal point have to be the digits that are repeating. Since the 2 is not a repeating digit, I have to multiply the whole entire equation by 10, so that later on, when I multiply by whatever I need to multiply by, I get rid of the repeating digits. So we'll start off with 10n equals 2.13 repeating. Okay. Now, 2 digits after the original decimal point, so we're going to take 0.213. We have to take our original problem, okay, and we have to multiply it by 1,000. We already multiplied it by 10 to get here. Here I have to multiply it by 100, so I took the original and had to multiply it by 1,000. Okay, because if I take my original 0.213 to get, so that everything is after the decimal point, I have to multiply by 1,000. So I now have 1,000n equals, okay, if you do this right, 0.213, 213, okay, this is what my decimal looks like. If I take that and I multiply it by 1,000, okay, 1,000 is going to get me, okay, 1, 2, 3 places, so I'm going to have 213.13 repeating. Okay, I'll mess this up. It's not 213 repeating, it's just 1, 3 repeating. 1, 3, 1, 3, 7. Okay, so I now have 10n equals 2.13 repeating, and 1,000n equals 213.13 repeating. Now I do the same process I did before. Subtract my 10n, subtract my 2.13 repeating. 1,000 minus 10 is 990, and 213.13 repeating minus 2.13 repeating is 211. Make sure you subtract carefully. So I now have 990n equals 211. Divide by 990. And as far as I know, I can't divide that any further. So n will equal 211 990ths. Totally different fraction than when we did 2.13 repeating. That one was 71 333rds. This one's 211 990ths. Converting a repeating decimal to a fraction is a more difficult skill, but as long as you learn the steps to it, it's not hard. You just have to learn the steps and then just do it and practice it several times until you're really good at it.